The root of modern cryptology lies within the events of World War II, in which Enigma and Turing machines were developed by the opposing forces to wage war in the world of information. This also laid the foundations for the development of early computers. The Enigma machine was developed by German engineer Arthur Scherbius at the end of World War I, with the objective of creating a code that was impossible to be broken. These machines contained rotors, a reflector, a plug board, and an electrical circuit. To use these machines, a message was typed on a standard keyboard layout, which would pass through a plug board, scrambling the letters. This message is sent out, and the receiving Enigma machine would produce the scrambled message using different letters than the original message, and the operator would then decode the message, based on a pre-planned pattern indicated by lights under the letter keys. This in turn would inverse the scrambling to produce the original message. The Enigma machine scrambled the messages using a complicated equation which was a product of permutations. Combining 3 rotors from a set of 5, the rotor settings with 26 positions, and the plug board with 10 pairs of letters connected, the Enigma machine would have nearly 159 quintillion different settings.
In 1939, mathematician Alan Turing was recruited to Bletchley. Alan had an interest in the mechanization of mathematics and had written papers on what he called Turing machines, which were basically mechanical calculators. The technology available at the time was not such that these machines could be built, but the idea was recognized as laudable. The Turing machine was hypothetical and could simulate any algorithm. It worked using an infinitely long tape that is divided up into squares in which each of the squares have either a 1, a 0, or a blank, and a sort of little machine that travels along the top of the tape reading the inputted data. At any moment in time, it is in a state. For example, in state 42, if the symbol seen is 0, write a 1. If the symbol seen is 1, change into state 17. In state 17, if the symbol seen is 0, write a 1 and change to state 6. The code starts with a certain pattern of 1s and 0s, which then follows these rules and changes the original 1s and 0s to a new set, and what is left over is the answer to the problem. This can be thought of as the original binary code. The Turing machine has set the bar for modern-day computing, where if a program works perfectly, we call it Turing complete. Cryptology is broken down into 2 parts: cryptography, which works on encryption, and cryptanalysis, which works on decryption. Both the Enigma and Turing machine were revolutionary for both sides of the cryptological coin, where the Enigma machine was a practical, functional, and a well-thought-out piece of technology, making obsolete the manual methods of encryption and decryption, whereas the Turing machine was a theoretical masterpiece in cryptology, which even modern-day technology can't match. In a sense, the Turing machine opened the theoretical doorway to computing, and the Enigma machine, the physical, and are the main causes of why we today get to enjoy an easy, rapidly evolving future.
It has been estimated that the work of Turing and his fellow code breakers shortened the war by several years. However, it is certain that they saved countless lives and helped determine the course and outcome of the war through their work in cracking the Enigma code.